everybody. Good day every day. Welcome to join the COSO free public webinar. This is Nina. Nice to meet you here. It has been a long time no see. Last 2 weeks, we have the course from the Mexico professor. Guess this time what professor we have invited. This time, we are glad to invite the professor from Jordan, Dr. Taher, to talking about his topic, the reciprocation in endodontics. And let's warmly welcome the Dr. Taher.
Thank you very
Hello.
much, Nina. Nice to meet you again.
Yes, Dr. Taher. How are you?
I'm doing very well. Thank you very much.
Yes, that's very good. This is the second time you are in our lecture.
Actually, it's my pleasure to be part of this lecturing group for the giant manufacturer in India, Coxswain. It's a pleasure and an honor as well.
Yes, that's very good. So before the course, let me do some the procedure. I have to introduce to some friends to let them know how to get the certificates.
Right.
So let me introduce it. In the first step, how to get the certificates. In the first step, you need to follow and like the COSO page. And one moment, maybe I share here is better.
And they can also follow and share my page as well.
Yes,
So I'll give a certificate from my side. Okay.
One moment. Okay, here in the first step, you need to follow and like the COSO page. And the second step is to leave your comments and questions below the our live. At the end of the live, we will share the link to the comments below the video. You can open the link and fill the form to submit to apply for the certificates. So above all step done, in 5 days, you can receive the PDF, the certificates in your email. And please know that the application for only few one times and only 5 hours in value in the lecture. So the form cannot be modified, and please make sure your information is correct. You can see the e-certificate like this way. And also we have the as you know, we have the special gifts for the doctor who join our course. The first gift is that we will have the lottery after the course, and the second present is that we prepare the best questions. We will choose the best questions to get the special presents, and the present is the SC Pro, our endo file. So please don't forget to leave your comments and get the certificates. So this is above our how to get the certificates, and we have the lottery goods for the dentist. So Dr. Taher, I think now we can start off your lecture now. Let's go on.
Thank you, Nina. Thank you very much. I would start by a question, actually.
Yes.
And welcoming. I would like to welcome all my friends who join us now. And
Yes.
special welcome to Dr. Mazen as well. He's now with us, and he will share his experience with us. I would like to ask the audience right now if they are using this location, and what is their current status regarding their location. So if the audience could answer, how many of you is using reciprocation at the current stage? Start from here. So if you notice that, guys, reciprocation is not really quite famous in our area, but it is more famous in Europe and in States. So you find that most of the dentists in Europe and States are using the reciprocation in their daily work. And we will look like why it's like that, and is it easier for us to use the reciprocation or to go for conventional rotary files. As an introduce for myself, I would like to say that thanks again for the Coxo for this introduction. I'm working now as an associate professor for Jordan University of Science and Technology, which is one of the top 400 universities of the world. I used to be a Saudi board endodontic mentor and supervisor in Taif for 7 years, and also I'm affiliated to the Royal College of Surgeons at Edinburgh. I'm an examiner for the MRD degree. I have lectured in many countries in the world and lectured for many manufacturers as well for scientific meetings. Um, Today we will speak about rotary night eye. In general, then we will speak about reciprocation, why we went and why we moved to the reciprocation, or how the reciprocation started. At the beginning, we know that we have the night eye, which has a very nice feature, which is the super elasticity. So we have the stainless steel file that we used to do the step back technique. They were stiff, they were causing problems, zipping, stripping, and perforation, and etc. Now we have a new file, a new material, the nickel titanium, that has a feature which calls super elastic. And when we cool that one or we stress the material, it will have some shape memory. Now, if we warm the material, it went back to the austenite super elastic form. So when it is outside the canal, it will go back to its normal condition. Now, the stress relation to the file related to the percentage and the amount of the stress. A little stress will not cause a problem, but if the stress exceeding a point around 8%, uh, there will be a transformation of the nickel titanium material to another material. It's called martensitic deformation state. And this deformation will continue until the file fracture while used. The first one to notice the importance and the benefit of having the nickel titanium in endodontics was the late Dr. Herman Walia. He published the iconic article in 1988 where he compared files, hand files made from nickel titanium to the conventional files. The same size, same geometry, same manufacturing process, only difference is the material. And he noticed that when rotating those files inside the canal, we end up with higher resistance to cyclic fatigue. The file doesn't fracture like before. So this gives an insight for the future rotary files. And since that time, we have many files with the same cross sections of the hand file that we have in our hands. So all the hand files, the cross sections that we know, we have rotary files are made like that. One of the earliest files that we have in the market was the Lightspeed by Steve Senior and the Profile GT series by Max Padden. For Max Padden, Dr. Max Padden, I think he's late now. So he was the one to start the profile, and from the name, it's a professional file for professional dentists. So the profile is similar to the K reamer that has a triangular cross section with some additives. They give it more taper, they make it a little bit wider, and they make it a little bit thicker with more taper, and they included what we call the land area at that time. So we could move from the hand file with multiple sequence to the new generation, the early generation of the rotary files, which is an austenitic file, which is super elastic, with the memory shape, but it has a limitation. And that was in 1990s. We had a land area where the file could be centered inside the canal while it's rotating. And most of them, they were having a fixed table. And this would lead to a screw-in effect. So the file used to screw inside the canal. And if the clinician was an expert, he can go outside the canal causing a transportation. Also, the file was in multiple sequence. It was faster than hand file. But now we have the single file technique, which is a single file that can do everything from the beginning to the end. Also, they use it in crown down technique. And the most famous example at that time, sorry for that, the light speed, the profile, the Quantac, the GT system, and the Hero 642. And this is one of the cases that has been done with such kind of files. If you notice, the canal are tapered, not an excessively tapered, but in the right way. The apical area was cleaned very well, and the final restoration was an amalgam layer. Since that time, we have many developments on the files. We have the tip that has been changed from a cutting tip to a non-cutting tip with different geometries. We have different cross sections. We have square cross sections. We have triangular cross sections. We have symmetry cross section. We have different cross sections. Also, we have the asymmetrical movement with asymmetrical cross sections. The famous one was the Rebo S and the Portable. Next, and now we have the two shapes. We have the lateral design, such as the XP shaper, the true shape that has different shape and different motion. We have also the change in the kinematics. We have the rotation versus the reciprocation and versus different kind of reciprocation. Also, the use of the glide path that has been standard now. Most of the files they use a glide path with them, and the thermomechanical treatment of the material that has been changed the characteristics of the files. And why we do have to change our files? Why we care about changing the files? The major problem that we are facing was the broken instrument. And we don't have Tiraushi to tell us how to retrieve those files and the other guys to tell us how to manage those files. So at the time that we have a severe curvature like those cases, we used to think how we can manage the cases without fracturing the file. It's not always possible. Sometimes we have to modify our files, and sometimes we end up with fracture, although we did everything right. So what happened after that? We have different modifications for the file that can help us to decrease the possibility of the file to fracture. This is an example of an osteolytic file. The file fractured very fast, within 3 seconds in a severe curvature. And those curvatures sometimes cannot be seen on the X-ray because it's in the buccolingual direction. And this is a heat-treated file, a different kind of heat treatment. It's the TF files with an R phase. And you can notice that the file would last for longer. So the heat treatment and the modification of the file design help to protect uh, the files from fracture. But the only thing that doesn't change was the canal anatomy. So the canal anatomy was standard. We could not change it. Too many ramifications, different angles, different canals with different specification. You can see the micro CT picture for the smaller. We have different ramifications, different angles. So the files would uh, uh, prepare those challenging areas with major difficulties sometimes, and with the possibility that we don't touch most of the canal walls. So we have to compensate with our irrigation and our uh, 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 chemomechanical disinfection. The file would only create a space for the irrigant to flow. And still, we have the major problem, the cyclic fatigue resistance, how we can decrease the chance for the file to fracture inside the root canal. Two ways they made to improve the life of the file so the file will not separate inside the canal. The first one was the heat treatment, and we will explain now how the heat treatment helped in decreasing the chance for the file to fracture. And the second one was the reciprocating motion by introducing different kind of reciprocating motion. And in this lecture, we will concentrate on those kind of reciprocating motion, and we will show how we can do the reciprocation even with rotary files. Now, the heat treatment, we started with the conventional nighttime, REGOS, for example. Then we moved to more heat treated files, the M wire phase, the R phase from CARE, the fire wire, and then we moved to the gold blue control memory wire and the control memory EDM. Now, from the gold and above, it's post machined files, and I think the M wire and the R phase was a pre machined file. And when we talk about pre-machine, it's the treatment for the material before grinding. And the post-machine is that they grind the material, they grind the file, they shape the file, and then they give it the heat treatment phase. So how the heat changed the material? All of us, we tried that. We used to do the operation with our material. We used to burn an instrument to cut the getaberka. With time, this burned instrument used to be softer with time, and we can bend it very easy. This has happened because while heating and cooling the metal, we end up with changing the internal structure of the molecules and the atoms inside. So the early phase austenite files, we have something called martensitic starting temperature, which is the temperature at which when the file reach that temperature will be in the martensitic phase. And we have the austenite starting temperature, which the time where the file will be on an austenitic phase. Now, it was a very small and it is within the body temperature. So the file, when it is introduced to the canal, it will be stressed in the canal, and the file will not be in the martensitic phase, but will start building at the deformed martensitic phase, which is a deformed layer that would cause eventually a fracture. So with heat treatment, we will increase this gap. So the file would enter the canal within the body temperature and will stay in the martensitic phase. That is a reversible stage and will not go for the deformed martensitic phase. So it has a big margin and big chance to keep the original structure of the file without changing. And the martensitic and the austenitic starting and finish temperature is wider now. The second way to decrease the chance for the file to fracture is by introducing the reciprocation. And in the reciprocation, you actually what we are doing, we are rotating the file in one direction and loading the file, and then we will deload the file. We will decrease the load on the file by rotating the file on the other direction. We'll explain that now in a minute. So most of the files in the reciprocation now is in a martensitic files. It's heat treated files, so it will give better chance to resist the cyclic fatigue. It has a reciprocation motion, which is different motion. We'll explain it. And this reciprocating motion increases the chance to resist the cyclic fatigue. Now also we have the single file concept, which is faster than before ever. We have single file that can shape the whole canal without going in a sequence. So it's much easier, and that's why in Europe and in States, majority of general dentists they love to do reciprocation. It will be easier for them to use one file and to finish the canal. And this is some of the examples that we have in the market: the TF adaptive, the reciproc wave one, and the arm motion. This is the reciprocation. So the file would rotate. Usually we have the file rotating in the clockwise, the CW. Now the file will rotate in the clockwise or in the counterclockwise, but then it will rotate in the other direction. There's two different angles, one on the right, one on the left. So if the file in the conventional reciprocation, we have the major angle to the left where it rotates more toward the counterclockwise and less degree to the clockwise. We'll see that now in a minute. The base of the reciprocation was started by two techniques. The balance force technique that we have it since 1985, and the watch wind that was introduced before. So the watch wind, we have a kind of reciprocation. We rotate the file in equal degrees to the clockwise and the counterclockwise with a little bit of pressure, and the file will go inside the canal. And we use it with the hand file to create a glide path. And we have the balance force technique that was introduced by Jim Swan in 1985. And in this technique, we will rotate the file on the clockwise, a 90 degree, and then we will slide the file inside the canal. We will slide inside the canal for like 180 to 270 degree, and then we will rotate again in an active mode to cut inside the canal and rotate again inside the canal. So what happened here, we will cut on small portion of the canal, not all the canal wall will be engaged, but we will slide the file and introduce the file to a deeper point in the canal. And this will help us in calcified and narrow canals and also in curved canals. The first one to notice that we can use this kind of motion on rotary files was Dr. Ghassan Yared from Lebanon, Canada. And what he did, actually, he brought an old motor called Technica RT, and he changed the angles by which the file is rotating. So the file usually rotates in 360-degree on a continuous rotation. He did that the file will rotate on the opposite direction for a certain degree, and then it will rotate on the other direction. So it will do a kind of alternating rotation, clockwise, counterclockwise. And he can shape safely a curved canal with only one file, the F2 from rotate. I have my little experience or little experiment. What I did, I brought a geometric handpiece, which is a handpiece that can do a kind of auscultation or a kind of reciprocating motion with equal degree to the right and to the left. And I did modification over the rotary file to make it fit on the tip of the handpiece. And I tried to treat a case with that one. And this is the case I treated. This is a panoramic view for the same tooth I treated. And this one is the follow-up for 12 years. You can notice that we can predictably shape the canal with only one file, the F2, at that time. The only problem that I faced with this little experiment that I noticed that the patient has more pain with this kind of reciprocation. And maybe the reason was that the file is designed to cut on the clockwise. So with equal turn, clockwise, counterclockwise, I tend to push debris outside the apex. That's why it caused more pain. Now, is the reciprocation causing really a better resistance to cyclic fatigue? A group of researchers by Giuliani et al. In 2012 tried to answer this question. So what they did, they brought Protable, the reciproc, which designed to be used in reciprocation, and they use it both in reciprocation and in continuous rotation. And they found that the chance that the file would be fractured with reciprocation was double that on continuous rotation. So the time needed to the file to fracture was double with reciprocation. So the chances is 2 to 1 that the file would fracture if we use the reciprocation with the same canal geometry, a 90-degree curvature. Another study by Gambarini et al. In this study, they compare the same file, the K3XF, which is a heat-treated file, with rotation motion and with different angle of reciprocation. And they found that whenever we do the reciprocation, the file would last for longer than the continuous rotation. It will decrease the amount of stresses on the file, and we will have a file that lasts for longer. And this is the motion of this. Now, this is important to notice that most of the motors that have ready-made reciprocation motion has the file rotated in the counterclockwise. So the file will rotate to the left, not to the right. All the rotary files rotate to the right. Now, this file, just watch the rubber stopper with the black dot. So the black dot is rotating to the opposite direction. There's two major angles. There's the major angle, the cutting angle, and the other angle is the reciprocating angle. The major angle is the one with a longer amplitude, and in this case, in the reciproc, it's 150, and the file here rotates to the counterclockwise. Why it is important? I'll go back to the same video again. Why it is important to notice that? Now, some of our colleagues, some of our colleagues try to use the same motion with rotary file. The file is designed to rotate on the continuous motion. So if you want to use this specific reciprocation motion, you should use the reciprocation files, not the conventional rotation files. Especially with the old motors that have ready-made, let's say, program with reciprocation. Okay. Now, The new motors, most of the new motors, and the Coxo have two nice motors. We'll speak about one of them today. They have the option to do the reciprocation either in rotation or in the counterclockwise. So you notice here on this slide that it gives you an option 150 and 30. The 150 here, it rotates on the clockwise. So I can use this motion in blue with normal rotary files. But the motion in red is designed for the reciprocating files. So it is important that you have to notice that this is a reciprocating file or a rotary file. Okay? The two major problems that we are facing with reciprocation, the first one is the debris extrusion, and the second one is the dentine microcracks. Let's answer that. So many of the colleagues, they don't like reciprocation because they say basically those files tend to fracture the canals, and those files tend to cause more post-operative pain, and the reason is the debris extrusion. Let's look for that. Why it happens this? Now, the reciprocation, when it cuts the canal, it will load the file. Now, when it will move to the other direction, it tends to push the debris to the sides. And by pushing debris to the side, it will cause the collection of debris, and with radiation, it might go outside the apex. And this is what happened. But is it true that the reciprocating files would always do that, or the rotary also can do that? Let's look for the literature. Okay. Now, there's too many articles in the literature, and personally, myself, I do a lot of studies on that. I'm interested to follow up the base extrusion and the post-operative pain. So, on the literature, we will find that on a systematic review was made in 2016. Uh, they end up to conclude that the reciprocation tend to extrude more debris than continuous rotation, but many studies showed conflict with this. So, on my experience, yes, we have extruded debris, but it's not significant all the time. This is a study we did with our group. So we compared two different reciprocating motion, the reciproc from VDW and the TF adaptive from CARE. And in this study, we found that both systems would cause postoperative pain. The postoperative pain was a bit less with TF adaptive than the reciproc, but at the 1 week, we have almost no pain with most of the patients. Okay. For the microcracks, different studies also compare the possibilities of uh, having microcracks from the rotary files and from the reciprocating files. And there's also conflicting on that. But recently, the Dias and his group uh, made a study, and what they did in this study, they compare the teeth before extraction and after extraction. They brought samples from cadaver, and the teeth was still in the bone. They made a scan for them, and then they extract them in a gentle way and keep them for dryness. And they scan it before and after. And what they noticed that when the tooth was inside the bone, there was no cracks. But when the tooth is outside, a crack was developed, and they attribute that the cracks most of the time would be a result of extraction and of dryness rather than the rotary parts. But why microcracks was important? The reason that the microcracks was important, and this is an accusation that the reciprocation is doing that, that another study showed that most of the extractions of the endodontic treated teeth was related to periodontal disease, but the third most common cause of extraction was the vertical root fracture. So the vertical root fracture would end up in causing 13.4% of the causes of the tooth extraction due to failure. So if we can eliminate the vertical root fracture or eliminate the chance that we have a fracture, we would preserve the teeth for a longer period. Another study explained that the taper has a relation to the vertical fracture, and in this study, they compare different taper. So they compared taper 10 and 12 to taper 4, and they found that whenever we have a higher taper, more than 10 or 12%, we have higher chance for the tooth to fracture. So the cervical area is the important rather than the apical area. The large tumor at the apical area doesn't cause fracture, but rather the over enlarging the cervical area would cause fracture. For example, the SX and the other orifice openers, the old one used to be quite large and they could cause the vertical fracture, and the newer one is more smaller in size and also it caused less destruction in the pre-cervical dentine. So the pre-cervical dentine, preservation of the pre-cervical dentine is important to prevent vertical root fracture. And here I have to show that post-preparation would cause more removal of the pre-cervical dentine. So we have to be careful with post-preparation and inserting post whenever we don't need. Now let's look for the reciprocating files that has been in the market. Most of the reciprocating files that has been in the market have the D16 between 100 and 120, which is with taper of around percentage 5 to 8%. So we don't have a very huge and large taper reciprocating file, and most of the file would not cause really destruction more than what is needed in the pre-cervical dentine. So we can consider that even the conventional reciprocating file still they are conservative. Let's assess what we have files in the market. We have the S1 Pro from Coxo. It has three different files with Tabor 7 and Tabor 6. We have the initial file that can be used as a glide path and it can be used as well as a shaping file for neural canals. We have the 25 Tabor 7, which is the primary file that can be used with most of the canals. And we have the 35 Tabor 6 with the large canals. And this is a case from their website. I did not try, unfortunately, this file until now. We don't have it in the area. Also, I noticed that it have a unique feature. The file have a cross section similar uh, uh, to the wave one goal and to the whatever next, but it has only one feature that no other file has, no other reciprocating file has. It has the asymmetrical cross section, which means that this file combines the reciprocation with the asymmetrical cross section motion, and this would give benefit over the cycle fatigue and creating more rooms for debris collection and decrease the amount of accumulation of debris outside because of the asymmetrical cross section will not touch all the canal walls coronally and it will create a room for the file for the debris to be accumulated in the file. Another file from Zark, it has Taper 5, which is nice for a very curved canal. It has different sizes as well, but the taper was nice. Uh, this is a case I did with Zark. You can see the difficulties of the canal. The canal was very narrow and very severely curved. I have to use a glide path file with this one because I have only the primary Zark, the R25, and then I use the 25 to finish the canal and obtain. We have also the R motion, and I'm using the R motion quite often in most of my cases. Today I did a case with the R motion glider C. So we have the glider, and we have different files, the shaping files, ranging from 20 taper 4 up to 50 taper 4. So the file can be used in a single file, for example, 30 taper 4 alone, or 25 taper 6 alone, or it can be used in a sequence. But most of the file now we prefer the sequence. This is a case done by this file, and you can see that we preserve the anatomy. We have the one recipe from Micromega. Also, it is an aggressive file. It has different taper and different sizes, and it can be used with a little bit change in the angle. We have the Wave 1 Gold, which is quite nice file. I never use it, unfortunately. It has the same motion. It has triangular cross section, and the motion is 150 minus 30. And also from Diltac, we have the T Endomust from Turkey. Also, they have a glide path and different files, primary, secondary, or large, and 50 for very large canal. And this is a case I did with this file. I'm sorry for the quality of the X-ray. but you can see it was quite difficult. We have the MB2 here, it's not clear. And we have the reciproc, the famous one, and those cases are done a long time ago with reciproc, around 8 or 10 years ago. And we have three different sizes. The primary are 25, R40, and R50. And this is the comparison for the files we have in the market, the cross section. So we notice that reciproc, the T-endo must have S-shaped cross section. And today I tried even the teeth system. It's also an S-shaped cross section. And with this system, we need to push a little bit more. The cutting efficiency with the S-shape is less. We have triangular cross section like the one Resi and the R motion. It has better cutting efficiency. We have the horizontal or the square cross section like the one with gold and the S1 Pro from Coxo. And most of those files have a reciprocating angle of minus 150 and plus 30. So the minus is the counterclockwise and the clockwise is 30. Except for the one receipt, it has the recommendation of 100 minus 170 and plus 60. For the S1 Pro, we have the primary file, and usually we start with file 10, and then we can go with our primary file, the 20 Tabor 7, and then we can choose either to go for the standard or the 25 Tabor 7, or if the canals are large, we can go for 35 Tabor 6. So we can choose which one to go for, and we can combine for both of them. For example, if the mesials are quite narrow, you can go for the 25 Tabor 7, and then the distal you can go for 35 Tabor 6. Do we need to go on a sequence? I mean, the 20, 25, 30. With reciprocation, you can go with single file. I mean, if the canal is wide enough, you don't need to go for 20 or 25, go immediately to 35. But if the canal is quite tight, it's better to go on a sequence, so it will be easier for the file to glide inside. And it is important to know that we need to push with reciprocation. It's not like the other kind of files. We need to have a little of pushing. So the file is not on picking motion, but rather on a kind of an active motion. Why we need the primary file? Do we need the primary file in most of the cases? Now, the literature has shown that using a glide path file would help in keeping the canal geometry centralized so we don't have transportation. Also, the debris exclusion are affected by the glide path file. In this study, they combined the glide path file with rotary and with reciprocating file, and they found that the glide path file decreased the amount of debris exclusion. This is another study with centering ability, and they found that when they use the glide path file in figure A, you can see that the file kept the S curvature in its place, while in figure B, where they don't use the glide path, we are over enlarging the canal and changing the structure. Also, an excessive bushing can make a damage for the file, so it's better to go with a glide path file first rather than single file in cases with severe curvature. The tip was not changed in this file, but you can see the case. This is the case, and I use single file. I push the file, and I end up with a kind of a ledge here, and quite changing with the curvature because I did not use the glide. So, can we use the reciprocation files in everyday case? The answer is yes. This is a case of retreatment with three problems. We have the infection at the distal buccal, we have the five metal post here, and we have broken instrument. So the broken instrument is not causing any problem. The fiber post, we have a little bit of space here on the metal post. So we have to remove it. We remove the post, we remove the broken instrument here. Okay, and the problem was the infection at the distal. The things that the reciprocation allow us to retrieve the files efficiently, and then we have to deal with other problems. In this case, the infection was the problem. Another case, primary case, we have a big lesion, so we treat it with reciprocating files. Here we use the R motion, I think 30 or 25, and we could prepare the canal and obturate with bioceramic seal. Okay. Another case with a severe curvature, narrow canals. So we use the reciprocating. This one I think was the one reci from Micromega. So we use the reciprocating files after creating the glide path, and we prepare the canal, obturate, and place the fiber post. Another case where we have very severe curvature and very severe calcification. We could not see the canals at all. So in this case, we have to use manual files after removing all the debris, and we have to build up the canals. Then we start our endo. So we did the build up. We prepare the canal. You can see the hand file after inserting them, and you can see that the palatal we have a large file because we prepare the canals to a certain point, and then we took the confirm the working length with an X-ray, also to assess the curvature, and we prepare the canal and obturate efficiently. Another case where we use reciprocating file, so you see the curvature here, and we did it, the same concept, same technique. Another case, third case. So reciprocation can be used in most of the cases today. Now we will speak a little bit about the motors, and we will be ready for answering the questions. Which motors are used for reciprocation? In the beginning, we have specific motors that can be used for reciprocation. The famous one from VDW, the VDW silver and gold, and in this one we have a motor with pre prepared reciprocation mode. So you choose the reciprocation, and you have to notice that in this case, the file is rotating on the counterclockwise. So it is important to know that the file is rotating in the counterclockwise, and you cannot use a conventional hand file in this case. I'm sorry, you cannot use conventional rotary file in this case. You should use a specific file like the VDW reciproc or the Wave on Gold or other reciprocating files. We have the new motor from Coxo, the Pro file, the sorry for the name, the I forget the name. I'll come back to that. And we have the also motor from Dell Supply, and this motor you need the iPad to be connected to the motor. It will be connected with a Bluetooth. We have also the new Smart A from Woodbaker. Also, you need an iPad connected to the Bluetooth or a phone connected to the Bluetooth. While in the Coxo one, you have the console that is already a charging device and also a connection for the handpiece. So the handpiece will be connected via Bluetooth to the file, and you can choose which kind of motion you need. And the unique feature of this motor, the new motor, that you can adjust your angle either in conventional reciprocation or in forward reciprocation. So with forward reciprocation, for example, you can use your hand file, your conventional rotary file in reciprocation motion. For example, if you have an F2 from rotator gold, you can use it with this motion as a single file. You don't need to use the whole sequence, and you don't need to buy a special reciprocating file. The new thing about this motor, it has an option that mimic the hand file with watch line and balance force technique. Let's watch this video. And okay, this video. Okay, so the smart pilot motion have different shapes and different motions. We have the first one. The upper shaping is used for the pre-cervical dentine, so you can use the file, the glide path. I'm sorry, the orifice shaper in continuous rotation. Whenever we have overstress on the file, it will go on counterclockwise, so it will derotate and it will disengage the dentine coronally without causing the file to fracture. Okay. Now, deeper in the canal, we need to use the glide path. And in this case, we can change the speed and the torque. But if the file face let's say, resistance. It will do a kind of a reciprocation similar to the motion of the balance force technique. So this would help in inserting the file deeper inside the canal without having the risk of fracture or having a risk of transporting the canal, especially in S-shaped curvature and on very curved canal. Now, for traditional preparation of the file, this file would allow to do a smart reciprocation in case the file has an overload of the file. So, for example, you are using the file and you don't notice that we have a severe curvature in the canal. So the load would tell the motor that this file are stressed beyond the limit and it can fracture. So the system will automatically change the motion from conventional rotation to the reciprocation. Also, it has an option with patency where the file can be inserted a little bit beyond the apex to keep the file patent. So it's the same. We have the upper shading for the coronal parts. You can choose it for the coronal part. Okay. Whenever we have excessive stress, the file will derotate in the other direction and will come out of the canal. So it will not fracture inside. Okay. I have some questions I would answer hopefully after this video finished. So if you notice here, we have a very short angle, which is similar to the watch line, and it will help in going inside the canal in a very severe or very tiny canal. Okay. Now the question: is it good to use the forward dislocation? This is to answer that we have study we are busy with. So we compare the forward reciprocation to other motion and to conventional reciprocation, and we found that the forward reciprocation was a little bit better than the conventional reciprocation, the conventional rotation. So actually, forward reciprocation is not bad, and we can use it in severe curved canal or in a challenging anatomies. So the motor would help us to do it without need us to think how we can do it in our self by let's say calculations. Now, before going to the Nina, can I answer some of the questions? Hello, Nina. Hello.
Hello, can you hear me, Dr. Taham?
Yes, I'm hearing you. Can we start answering some of the questions?
Yes, now we can select the questions. Your lecture is
But
very great and
yeah,
nice information for the reciprocate file. Many thanks for you sharing this pressure information to the dentist. Uh-huh.
yeah.
Uh,
Thank you very
so
much for that. Yeah.
so now let's see the dentist friends the questions.
Okay.
Can you see the
I would like
questions
to start
now?
first by thanking the guys, everybody to attend this webinar. It's my pleasure actually to have you here, guys, and
Mhm,
really it's not something I appreciate that I'm
mhm,
seeing you here. Now, just to sum up the ideas, we have to understand that we have the reciprocation, the conventional reciprocation, which is that
mhm,
the file rotate in the counterclockwise. The file will rotate to the left, let's say. Okay, the major cut will be to the left. Now, can we use the normal rotary files in reciprocation? The answer is yes, and we can use it usually with the new motor. It will do it by itself, so you don't need to think about it. So you can get the motor, for example. I'm just waiting it. Hopefully you will have it soon. So you can use the motor. It will do the work for you. This is number one. Now, if I have specific reciprocation file, let's say if I have the reciproc from BDW, so I need to choose with my motor the reciprocation motion, and it should be minus 150 plus 30. This is the usual reciprocation angle. So it's important to notice that it should be on the counterclockwise. I will put something on the tip of the file and rotate it. It should rotate on the other direction, to the left, not to the right. If it's rotating to the right when I'm looking to the file from the top, this means it's rotating in a conventional rotation way. And those files are designed on the opposite. If I have a conventional rotary file and I want to use it in reciprocation, I can adjust the angle to make it in reciprocation. Now, I'll start answering some of the questions. Dr.
Please.
Yuji, in calcified canal, when we find difficulties to achieve glide path, how we manage such cases? Can you elaborate on management of care canals? Okay, thank you very much, Doctor. In curved and difficult canals, we start with orifice shavers, usually. So in reciprocation, you can use it as an orifice shaver. Initially, you can make a glide path after that. So when you create the space coronally, you would have better chance to negotiate the canal epically, and also you'd have more elegant inside the canal, and it will be easier to negotiate the canal until your file 10 can go to the full length. Now, it's important to know that most of the reciprocating files are promoting that you can use it immediately after file 10, but now too many systems are including the glide path with their file. So
Mm.
if you have a difficult canal, curved canal, just calculate your canal, make it on a zone option, zone ideas. So the coronal part first, and then negotiate the first part of the canal or the first part of the curvature. Let's say zone B, it will be, or zone two. With your hand file, insert your reciprocating file up to that point, and then go for the full curvature at the end after you create a better funnel coronal.
Mm.
Okay.
So let's see next questions.
Yes, I'm looking for that. Dr. Muhammad Abbas, how is the reciprocating motion of the piston and connecting rod is converted to rotary motion? I could not get that exactly.
Mm-hmm.
Now, let's again talk about the reciprocation. Dr. Muhammad Abbas, he asked a question. I could not get exactly the question. The piston and the connecting rod. Now, usually you have your file in rotation with reciprocating angle. If you are using the conventional reciprocating files, it will go in counterclockwise and it will do the reciprocation on the clockwise. If it's the opposite, you will do like that. But those files are not used usually with the lip clip if you are asking like that on the patient. I mean, we don't use it with a lip clip guided or an epic locator guided. It will go on a conventional way. It's like a drill inside a wall. You will drill the canal more than you will have the file rotating until it reach the abyss and it will derotate like the Morita, if you are asking about that. Hopefully, I answered. Okay, for the broken instrument, now there's like too many studies showing that if the broken instrument at the apex, usually it will not cause failure because usually if we are reaching the apex, it means that the apex is key. And I have many cases with broken instrument at the apex. Yes, we don't need to retrieve the file in most of the cases, and you can fill over that one and just do a follow up. I have one case with 12 years follow up. It's my sister. The problem with patient mentality, some of the patients they refuse and they want to take it out whatever happened. I mean that case, the one I showed for retreatment, the problem was the distal canal, the distal buccal canal, not the mesobuccal at all. And I would say that the problem that the patient would not allow or would not accept that we will not remove it, so I have to remove it. That's all. Is there any particular specification of a case that would be handled better with reciprocation instead of reciprocation? For me, any curved canal, any challenging canal, I would go for reciprocation. Now, you can use specific narrow files, heat-treated files, whatever for narrow canals, but reciprocation is safer. For the metallurgy, if we can use in reciprocation and rotation, there's no specific metallurgy. You can use it like that. But the thing is that the file design. If the file design in reciprocation, it means that the flute is on the reverse. So it will cut on the counterclockwise motion, not on the clockwise. If the file is designed for rotation, it will cut on the clockwise. This is the difference. Yes, there's many motions. We tested a couple of motions. An OTR, for example, optimized torque reduction, which is a continuous rotation with specific reciprocation. If we are at the higher torque level, we will set up the torque level. We have the TF adaptive motion. The adaptive motion is actually a kind of a continuous rotation, and when you are facing a specific challenge or a curvature or a stress, the file would start going on reciprocation, but both are still on a continuous rotation, not on reciprocation as a reciprocation. If we are talking about conventional reciprocation, we are talking about the file rotate on the counterclockwise.
Let's see
Is
the
there
next
Dr.
one.
Hussein talking about if there's a difference between different reciprocating angles? Yeah, it make a difference. Yes, sometimes. Now, different reciprocating angles would cause, for example, that the file would rotate more or the file will cut more and will be de-stress a little bit less, like that. For example, if we have the 150 minus 150 and plus 30, which means every cut we have 120. Three times we have a full rotation. But if we have the 210, for example, and 60, for example, or whatever, so we have 150 at the end. So two turns will do the full rotation. So it's more closer to the full rotation. When we have a larger angle, we are more closer to the full rotation. Rotary or reciprocation, how I choose the best for me, I would go for the easiest. I mean, if I'm good with rotary, it will be fine, but reciprocation now is moving in the world. It's the more easy, acceptable technique. Also, I have to say that it has the shortest learning curve. So if you grab your reciprocating file and you start working with it, usually you don't change it because it's easier and faster. Just you need to do one session of training and you are ready to.
Let's
Yes,
see the
for the
next.
irrigation now, when we are using reciprocation and we finish within 5 minutes, I totally agree with you. We don't finish our treatment. We have to irrigate and we have to compensate with irrigation. If I could not irrigate and do an activation and all that, we have to go for dressing the canal with calcium hydroxide. So the time that needed to be cleaning the canal is less, yes, but even though such a canal with 3, 4 files, still we are going to finish within 1, 2, 3 more minutes. So we have to compensate with irrigation all the time with whenever we have a short treatment. Can we use, Dr. Rami, can we use normal files in reciprocation? Yes, we can, but we have to change the motion. Not all the files would allow us to use the files in reciprocation motion. So it is important that guys should know that if we are using our hand file in reciprocation motion, we have to choose the right angle. I mean, for example, I'm using the F2 Pro table in reciprocation. So in this case, I have to use the uh, change the angle and not use the conventional reciprocation motion. I have to use a special motor that can give me the can give me the right angle. I mean, the positive reciprocating angle, not the negative reciprocating angle. Okay. I'm looking for the comments because I have my, unfortunately, I have my phone switched off. So, Nina, can you help me? If there's any questions?
I think no more questions. The other comments
Okay.
is many thanks for your presentation, and the comments you are very wonderful, professor.
Thank you. Thank you very much. Thank you for everybody attending.
Thank you,
Okay.
everybody. So hope we can meet you in next time in our webinar. Because you already have the friends in our page.
Yes. Thank you very much for everybody.
Thank you, Dr. Taha. So, see you next time. So that's
Inshallah.
all
Thank
for
you.
today, the lecture. So let's see the webinar in next week.
Okay. See you.
Thank you. Have a nice day. Bye bye.
Thank you.
Thank you.
Okay. Thank you very much.
Thank you.